on the keyboard.
It's not working. That's see. Oh, finally, it's working. Okay, sorry about that. So it is no longer news that the German cockroach Platella germanica is an insect that predominantly lives indoor. Understandably, this has become a source of annoyance for most homeowners because it moves between field and food and by chance contaminates foodstuff. And when it is not contaminating foodstuff, it is leaving trigger-causing allergens in its wake. Besides, these guys are unsmitey and don't smell great, justifying the need for control. And we all know it is incredibly difficult to control the German cockroach once it is established. One area of German cockroach management in recent times that is starting to gain attention is the use of essential oils. Typically, toxicity studies are often used to rationalize the insecticidal activity of these oils. At best, this information gives us the gram per body weight that is necessary to achieve a kill or an effect. But we often don't know how these essential oils actually do work. For example, through published studies, we know that limonene, cavacrol, and beta-2-gergelicin, when applied topically, penetrate to the intersegmental membranes and exert their effects. And we have studies from fumigation studies showing that these oils have the propensity to pass through the spiracles of the insects to achieve their effect. So we think that if these oils can pass through the spiracles, there is a chance that they can modulate the coordination of the spiracles such that they affect the gas pattern produced by the German cockroach. For any insects, there are three types of gas patterns that can be produced. You have the discontinuous gas exchange known as the DGC, you have the cyclic, and you have the continuous. We chose the DGC because the DGC gives a reflection of what is happening to the spiracles at given points in time. It starts with a closed phase where you have these parallel lines where the spiracles are short and there's negligible exchange with the external environment, followed closely by a flutter and an open phase where the spiracles are open and you have gaseous exchange with the environment. Another way to look at this is to just say you're comparing the interburst, which is just the closed phase, to the burst, which has the open and the flutter phase. So for this study, what we are asking is, given the discretion and the division between DGC, can we see what the effects of these essential oils are by comparing how it affects particular coordination and how it affects the interburst to the burst stage? As a consequence, the objective of this study is to investigate the effects of limonene, cavacrol, and beta-2-gergelicin on the DGC characteristics among these big germanica strains and investigate probable water cost of these oils on the strains. To answer this question, we employed flow-through respirometry, which is the diagram you have to the right. Basically, we pulled outside air through a pump and we passed it through a dryad and ascaride column. The idea is we got rid of the CO2 and the water vapor in the outside air before being sent to the insects. Now, we allowed the insects to respire for like 30 minutes or so to establish DGC. And after DGC was established, I threw a repeating dispenser penetrate because this was a Tygon turbine which self-anneals upon the removal of the dispenser. I topically applied 1 microliter of each oil and we continued measuring the metabolic rates to see what happens. So the first interest of ours was to see what the recovery rate was like for each of these essential oil. In general, we observed an inverse relationship between the dose and the DGC recovery rates. And by inverse relationship, I mean, as the dose progressed, increased, we had lesser and lesser recovery rates. In particular, we saw for cavacrol that the recovery rate was much lesser for cavacrol. And we think if cavacrol could affect this particular coordination such that it took longer to reestablish DGC, we think in instances where you have particular permeability affecting resistance, cavacrol might be a good synergist because it affects periodicular coordination such that the spiracles are open, they can't really close for a prolonged period of time. As such, you would think that with cavacrol, you could use it, employ it as a synergist to ensure penetration of other control agents into the German cockroach. But we were not just interested in that. We wanted to know more. We wanted to see how these essential oils affect the metabolic rate and water loss in this insect. So to do this, what we did was we compared the period before we applied the essential oil. The red arrow you have here is the point at which the essential oil was applied, and you have the DGC before then and the DGC after then. So what we did was we compared the metabolic rate before application of essential oil, and we compared metabolic rate after the DGC was recovered. For the water loss data, what we did was we compared 20 minutes before DGC, before the essential oil was applied, and 20 minutes immediately after the essential oil was applied, just to see what the water cost of these oils are. For the metabolic rate data, what we saw for limonene, carbapenem, and beta-2-gypsum was there was a change in the metabolic rate. And if you look at this figure, for example, you could see that the metabolic rate clearly jumped, and there was a change in the duration. Say for carbapenem, for example, you'll see when you look at these spikes, they look more closer when compared to after application of the essential oil. So we saw significant changes in volume and duration of DGC after the application of this essential oil. So we think that from a control standpoint, these increases are likely to drive a substantial water loss. Interestingly, the water loss costs were not absolute. On the y-axis, what you have is the average water loss in microgram, and this was the dose of the essential oil. For limonene, we could not make a sense of the data because everything was all over the place. But for carbapenem, we could see that there was a significant increase in water loss when carbapenem was applied. So we think that, given the inability and the inconsistency of this data, we think water loss data is not absolute, such that whether or not the essential would trigger water loss is dependent on the insecticide resistance profile and the insecticide chemistry. To summarize, we can see in this study that DGC can be used as a metric to infer the physiological effects of essential oils, and we think that these effects are likely to be influenced by the resistance profile of the insect. And one general trend in our data was the immediate cessation of DGC following the application of the essential oil. So we think this hyperactivity might be due to the GABA receptor, and we think one follow-through from this study is to investigate the GABA receptor as the probable mode of action of this essential oil. And finally, we see that from this study that carbapenem inflicts the most damage to Blatella germanica. Of course, I would like to acknowledge the funding agencies, my advisors, Dr. Hu and Dr. Appel, and my lab mates. If I have the time, I would like to take questions. Thank you.
We do have a minute or two, waiting for some questions to populate in the chat if anybody has questions. Looks like you left them speechless.
A few did, Kyle.
Did? No, I'm not.
From Zach.
I'm not showing any new comments. Do you? If you have them, do you want to ask?
Yeah. What?
Joel's got one.
Yep. What do we know about other insecticide exposure and insect DGC?
Well, there's not so much that has been done with, particularly to essentials, asking if essentials affect insect DGC. However, for the more conventional insecticides, we've seen that yes, they can affect the DGC characteristics of insects.
Thank you. And many essential oils are repellent. Any idea how you'd use the essential oils practically?
Yeah, so that has been the major challenge with essentials, saying they are repellent. And how are these essentials repellent? One question that I'm asking with part of my research is to say, I have not seen so many studies that are done to characterize the antenna responses of these insects to essential, say EHG experiments with particularly German cockroach. Only very few studies have done or gone in that light. So one way might be due to first, let's establish this doing EHG experiments And once we can establish that these things are repellents, then we can go on to look for ways to add essential oils to other control agents. For example, in one of my published study, what I did was I employed super absorbent polymer gels because I saw that German cockroaches love water more than they love food. If you do not feed them, provide water for a considerable period of time, they will be fine. So we could look for other attractants, and we had essentials to those attractants. So you have something to bring them. Think of the push and pull strategy. So you have something to pull them, then you have the essentials to kill them.
All right. I am not sure why my